Okay, so we are recording, we are live. Today we're going to talk about surface area of polygonal prisms. Okay, so those of you who have Chromebooks, please close them up. You guys probably want to still pay attention to this, and then you can go back and fill in your notes later. So we're going to be creating a formula for the surface area of polygonal prisms. This means any kind of polygonal prism. Polygon meaning it has some sort of a shape that's a polygon, like a closed normal shape, like a triangle or a pentagon or a hexagon as its base. David?
And a polygon has a straight line.
Yes, polygon has to have straight lines. We're actually going to do one that's not technically a polygon. We're going to do one that has a circle as a base. So we're going to kind of derive the formula, and then we will.
Pardon the interruption. All ball games for today are canceled and rescheduled for tomorrow. Junior high softball will have practice after school from 3 to 5 in the gym.
Okay, now, this is the worst page to forget my drawing of, because to draw this, what we're going to do is we're going to draw nets. I hate to draw things. Okay, so if I were to draw a net of this, if I were to unfold this, kind of like yesterday I took this box and I unfolded it so you could see what it looks like, and except for the flaps that would be folded in, you get an idea of what the shape looks like. If I were to draw a net of this, what I would do is, how many lateral faces do I have? How many of those rectangular faces? David? Three. So I'm going to have the front face. That's this face. Then I'm going to have another face. The next face is not going to be quite as long as the first face. And then the next face is going to be this smaller connecting segment. So it's going to be even a little smaller. So there's my picture of the lateral faces. Now I'm just going to take the base and I'm going to draw it on the top. It would be here, and it would be sticking out here. So once we folded it up, imagine this folding around, it would touch all the sides of the triangle and it would look like that shape. So if we wanted to find the area of this, the first thing we're going to need to do is we're going to need to find the area of our triangle. Now, it does not tell you this here, but we're just going to say we would need the area of the triangle times 2, right? Because we have 2 of them. So we have a triangle on top and a triangle on the bottom. We have this triangle and we have this triangle. So we're going to have to find the area of the triangle. So we're going to have 2 of those, plus we're going to have the area of each one of the lateral faces. Now this lateral face is, let's see, we're going to have C times H, because the length of it, the width of it is C, the length is H. So this is H, this is C. This one we have C, and we have, this was the one that had, no, sorry, that's B. I have 2 C's, what am I doing? Okay, this one's B, and we still have H. This one's A, and we still have H. So we're going to have plus C times H, plus C times B, plus C times A. Now, work we did with expressions. I'm going to simplify this a little bit. I'm going to say I have 2 times the area of a triangle. Since I have a C in each one of these terms, I'm going to factor it out, and I'm going to say C times H plus B. Wait a second. Oh gosh, I did this wrong. Hang on, let me go back. Oh, that was really bad. Okay, I'm going to go back up to here. That should say H, not C. Sorry about that. That's C times H, length times width, B times H. I'm trying to go too fast. And then A times H. So the common thing is not C. What is the common factor that they all share? Well, they all have an H. So we need to take H times C plus B plus A. Okay, so that's our triangular one. Now we have the rectangular prism. This is, we already know how to find this, but we're going to do it this way with our net. So we have this front face, then we have a narrower face, and then we have the, that's a little too long, and we have the wider face again, and then we have the narrower face. So the length of this is A, so here's A. The length of this is B, A, and B, and then this is H. And then up on top, we also have a rectangle. So I'm going to draw these flaps on the top. Okay, not bad. I hate to draw this. Okay, now we have the two rectangles on top. So we're going to need to find 2 times the area of those rectangles on top, plus now we have 4 lateral faces that we have to find the area of. We're going to have A times H, and then we're going to have B times H, and then we're going to have A times H again, and B times H again. So this looks a little different than the formula that we did before. This one's a little complicated. What factor do we have in common in these terms that are left? David? H. We have H again. So we have plus, we take out an H, and inside we have A plus B plus A plus B, which we could also write as 2A plus 2B in the middle. Okay, last one. This one's going to be really fun to draw. What is the name of the base of this shape? I should see more hands for this. This is just naming a shape. What is this shape? Let's see, Bella. It is a pentagon. A pentagon has how many sides? 5. So I'm going to have 5 sides. Now this pentagon kind of looks like the first is a little wider than the second one, so I'm going to make a fairly wide piece. And then it looks like it has a narrow one, 2 wide ones, and another narrow one. So I'm going to go with a narrow lateral face, 2 more wide lateral faces, and finally a narrow lateral face. And my first face is A along the bottom. My second face, what does that say, is E. The next face is D, and then C, and then B, and they're all H top. Now I need to draw the pentagon up on top to be my little thing to close the box. It's kind of squished. There we go. That's as good as it's going to get because I'm kind of out of space here, so I'm going to draw. Okay, so that's a really rough looking pentagon. Hopefully you guys have better works of art on your paper than what I have here. So in this drawing we have 2 pentagons. We would have to find the area of the pentagon, which we don't know how to do, so don't worry about that. So we're going to have 2 pentagons. I'm just going to write area of the pentagon, plus we're going to have the area of the first shape, which is HA, the area of the second shape, which is HE, plus HD, plus HC, plus HB. Again, what do we have in common for all of those? What variable does each one of those terms share? Taylor? The height, again. So we have 2 times the area of the pentagon, plus we're going to take the height, and we're going to be left with A plus E plus D plus C plus B. This in the green, if you're having trouble, or in the blue, is HC plus HB. Okay, do we all get this? Okay, I'll give you a second. Yeah, I know. Oh, I'm sorry. I need to put this up again. Okay. I am not going to ask you guys to reproduce all of this. I just want you to understand where the formula comes from. I don't like to just say, here's the formula, use it, because what happens is, if you forget the formula, which on the PSSA, you're not going to forget the formula because they're going to give it to you, so it's not going to be a big deal if you forget it. But in real life, say you wanted to find the surface area of something, you just need to understand how you find surface area and be able to reconstruct it. I have very few math formulas actually memorized in my head, but I know the process of what I need to do to find it. So even if I don't know a formula, I can still figure out what I need to know. So that's what I want to make sure you guys have that kind of understanding. Are we good to go on to the next page now? Okay. Now I want you to look back at your picture. What do the nets of all the polygonal prisms have in common? They all have one thing in common. Go ahead, David. What is it? Yeah, what is it? They all had an H, didn't they? Now, we don't use H in all prisms, but these are actually called the width of the prism. And then we actually already wrote these expressions. We had, so I'm not going to write them here. They were on the previous page. We did 2 times the area of a triangle plus H times the sum of all of the lengths of the faces, and rectangular prism, pentagonal prism. And then which value appears often in each expression? We kind of already answered this up here. It was the H, because every lateral face, as we're finding the area, we have to use this H. I'm not going to do all of this. Let's see, what is the expression left? H parentheses. Okay, this I do want to talk about. If we go back to our page from before, and we look at what's left inside the parentheses, what does this represent? If I'm adding together C plus B plus A, I'm adding C, let me trace this so you can see it on the video, C plus B plus A. What's left in parentheses here is A plus B plus A plus B. Here we go, A plus B plus A plus B. And then down here I'm doing B plus A plus E plus D plus C. What am I finding when I'm adding those things together? Megan? The perimeter. Yeah, that's important to know. I'm finding the perimeter. So the expression represents the perimeter. Okay, so our formula for the area of a polygonal prism can be simplified to this. Area equals P times W plus 2B. This 2B is what we had at the beginning of all of our things. We had the bases, right? And we had to find the area of the bases. So if we look here, we had 2 times the area of a triangle. That's 2 times the area of the base. 2 times the area of a rectangle. 2 times the area of a pentagon. So this big B stands for area of the base. So B is the area of the base. P stands for, what do you think? Perimeter. P stands for the perimeter of the base. And then W stands for width or height or whatever we want to call it. It's the length of the lateral segments. What is the length of the segments that is connecting the 2 bases? So W stands for, we'll call it the width, because it's W and we want it to kind of go with the W. Okay, let's look at how this looks. That was kind of complicated, a lot to think about there. I'm going to simplify it now on the next page. Okay, we're finding the surface area of this triangular prism. Here's our formula. So before I can apply the formula, I want to make sure I know what P and B are. So first I'm going to find the perimeter of the base. Now the bases are always the 2 shapes on the end. So this is my base. What is the perimeter of that base? Anna?
12.
12, good. 4 plus 3 plus 5 is 12, so the perimeter of the base is 12 centimeters. What is the area of the base? Angelina, try that. No. The area of a triangle is 1/2 base times height. 6. It would be 6. Good. We have the base is 4, the height is 3. This is a right triangle, so we can use the segment in the triangle. 12 times a half is 6. So the area is 6 square centimeters. So I'm just going to, I should have written that over here. This should be over here. 12 centimeters and 6 square centimeters. What is W? What's the length of that connecting segment? Trey? We have this base and the other base is back here. What is the length of the segments connecting? No, the 5 is standing for this. What I want is, yeah, I want this one. So W is 6. So now what we have to do is just put all of those into our formula. So we take the perimeter times W, which is 12, times 6, plus 2 times our base, which is 6. 12 times 6 is 72. 2 times 6 is 12. So when we add them together, we get 84. So the surface area is 84 square centimeters. Now, I'm not going to ask you to find the surface area of anything that you don't know how to find the area of. So I wouldn't ask you to find the surface area of a pentagonal prism unless I told you what the area of the pentagonal prism was, okay? Because that wouldn't be fair. You wouldn't know what you were doing. So most of what we do is going to be triangular. There's a trapezoidal prism, a parallelogram prism. I also have a circle one thrown in at the end because we have done circles before. Technically, a circle's not, it doesn't have all straight lines, but we can still do the same thing. We can still use the base. Okay, let's go on and try another example. We'll do another triangular prism. There's an error on this.
What's LA?
I have no idea why that says LA. That should be PW again. Yeah, scratch that LA out. I have no idea what LA. I don't think any of the rest of them say that. No, something weird happened when I was typing that, I guess. So it should say PW plus 2B. Okay, so let's first find the perimeter of the base. Emma, what's the perimeter of the base? 12. It's 12 again. It has the same base as the last triangle. So then what's the area of the base, Max?
6.
6 again.
Just a reminder, all ball games for today are canceled and have been rescheduled for tomorrow. Varsity and junior high softball will have practice after school from 3 to 5 in the gym. Junior high baseball will have practice at 6:30.
Nathan, what's W for this?
5.
No, W is the length of the segment connecting the two bases. So here's one base, here's the other base.
3.
No, we want the length of the segments that are connecting the bases, these segments.
11.
11, there we go. So W is 11. Bryant, tell me how I plug these into the formula.
12 times 11 plus 2 times 6,
Good. 12 times 11 is
103.
good. Plus
12,
12, and what does that equal?
144.
Good. 144. So the surface area is 144 square centimeters. Okay, let's see how we get time here. The next set is a whole bunch of triangles for you guys to practice, but I want to go on and try another type of shape. So I'm going to skip the rest of the triangles. We're going to go on to another polygonal prism. Madison, what shape is the base of this prism? It's a trapezoid. So here's our base. And this one isn't drawn. We can't see the other base, but it's back there, right? So we can't see that face, but it's there. Those are the bases. Myra, what's the perimeter of the trapezoid? I didn't get 30, but I could be wrong. David? Did you get?
36.
No, that's even bigger than what I got. Did anybody get something different? Megan?
29.
That's what I got, 29. Let's just double check that. 5 plus 7 is 12.
Oh, you said perimeter.
12 plus 9 would be 21, and 21 plus 8 would be 29. You were adding in your head too, so you just got one off. Okay, so the perimeter of the base is 29 centimeters. Remember, we don't include this line because it's inside. We're only adding together what's on the outside. Question, David?
I'm just saying area, that's what I said.
Oh,
for
you
the
wanted to-
perimeter.
okay.
I thought you said area. that's why I
Okay,
said
okay,
36.
so you're saying the area is what?
36.
36? Okay, let's check that. So area, we need to do base 1 plus base 2, which is 14.
I was thinking it was base times height.
And then we need half of that, and then we need to multiply times the height. What's our height?
4.
4. Okay, so now tell me what you would end up with. 28. The area of the base is 28 square centimeters. So let's figure it over here. 29, 28. What is W for this? Megan? 6. Good. W is the length of the segments connecting the bases. So W is 6 centimeters. Okay, let's plug it into the formula. Jake, tell us how I plug that in.
29 36 plus 2 times 28.
Okay, good. Can you, do you have a calculator? Go ahead and solve that. A couple people solve that so we get it back up in case something gets typed in wrong. So 29 times 6 plus 2 times 28. We'll give Jake the first shot. 230? Did the rest of you who did it get 230? Okay, good. So 230 square centimeters. Okay, next one is an example of a parallelogram. How do we find the area of a parallelogram? Reese? Base times height. So what would the area of that parallelogram be? Sure.
78.
78, good. The area of the base would be 78 square meters. What would the perimeter of the base be? Kayla? 40, yes. 40 meters. The perimeter is 40. The base is 70. Area of the base is 78. What is W for this? Casey? 2. Good. W is the length of the segment connecting the two bases, so it's 2. Okay, and then we would just fill all that into the formula, which I'm going to skip for right now because we're running low on time. So you would just put it in the formula. Now, if you were to look in your textbook, this is called, well actually, let me ask you, what shape is this? Does anyone know what the name of it is? Bryant? No, it's not a sphere. Angelina? It's a cylinder. Sphere is the one that's like a ball, like these things I have hanging from the ceiling. Those are spherical. This is a cylinder. If you were to look in your textbook for the formula for surface area of a cylinder, and it is in your textbook, you would find a completely different formula. That's because they try to take the formula for area of a circle, since the bases are circles, and they just put that in the formula. But it's really the same formula. We're still finding the perimeter of the base, which in this case, the perimeter of the base is not called a perimeter. What's it called? Circumference. So what we're doing when we're finding this one is we're finding the circumference of the base. Do you remember how to find the circumference of a circle? Bryant?
Diameter times pi.
Good. What's the diameter of that circle?
6.
6. So 6 times pi would be what?
18.84.
Okay, 18.84. So what we're going to use for P is actually the circumference of that circle. How do we find the area of the circle? Michael, do you remember that?
Radius times radius times pi.
Times pi. So it's pi times the radius squared, or radius times pi. Can you do that, Michael? So 3 times 3 times pi. Give us, I know what it's going to be.
28, 26.
28.26. And then what is W, David? 9. And then we would just put that all into the formula again. Okay, any questions about what we're doing? I think the hardest thing in doing this is deciding what your bases are. Sometimes people have trouble deciding where the bases are. In the worksheet that I have for this homework, I do some of the work for you, and I have places for you to write all this just like on your notes. Let's see, turn this off.